Good morning or good afternoon, everyone, and welcome for JavaCard Forum third webinar of our 2024 webinar series. I'm Jean-Daniel Ostel, the president of the JavaCard Forum, and today's webinar is a talk on JavaCard Development Kit, a one-stop solution for applet developers. It will be given by Nicolas Ponsini of Oracle and Syamkumar Cheedela of Infineon. Nicolas is consulting product manager at Oracle within the Java Platform Group, and he leads the JavaCard product management. Syamkumar is lead principal engineer at Infineon and works in tools development for the digital security and identity group. JavaCard is the platform of choice for interoperable development on secure elements and smart cards, and it has been for over 30 years. Developing for JavaCard requires special tools and skills as the bytecode, language, runtime, and associated toolchain are different from those of the Java language. Big players in the industry are usually developing for the JavaCard platform within our software development toolchain, but it's also important that smaller players who do not have the means to develop and maintain such tools have access to development kits to develop and simulate their JavaCard applets or packages. In this webinar, Oracle and Infineon will present the latest Oracle software development kit that will surely help JavaCard developers in their development process. You will be able to ask questions at the end of the webinar. The microphones are mute for now, but you have a chat window where you can also ask questions directly in the chat window. This presentation is recorded and will be available both on the JavaCard forum website and on the JavaCard Forum YouTube channel. Without any further delay, please welcome Nicolas and Syamkumar. Nicolas, Syamkumar, the screen is yours.
Thanks a lot, Jean-Daniel, for the introduction, and hello, everybody. I'm really happy to present this webinar today. First, because on behalf of the JavaCard team, I'm thrilled to announce that we released the latest version of the JavaCard development kit just 1 month ago. And today we will focus on introducing and showcasing it, actually. And second, because it's a pleasure to co-present this webinar with Syamkumar from Infineon, who has done excellent work with the JavaCard development kit and provided great feedback. Overall, this webinar is for developers who want to learn about the features and capabilities of the development kit and those looking to develop JavaCard applications overall. In the first part, I will explain the purpose of the JavaCard development kit, its main goals and value proposition, and then I will dive into its specific features. In the second part, Syamkumar will lead, I would say, an how-to session showing how to use the kit to develop and debug applications. Syamkumar will also show how it can be used for testing applications and how it integrates well with existing tools. So why this JavaCard development kit? First, a slide about the context and the role of JavaCard in the certified security ecosystem, while I'm sure it may just be a reminder for many of you. In our everyday lives, whether we are making a payment, crossing a border, making a phone call, or passing healthcare exams, secure operations are involved, such as authentication, authorization, data protection, and access control. And for these operations to be trusted, they need to be certified. This is achieved through the use of a dedicated hardware called a secure element, along with a framework called JavaCard, which, as we see here in this picture, really plays a central role because it ensures interoperability and it allows for a choice of product implementers and solution providers. Together, the secure element hardware, the JavaCard framework, and the applications running on top, they form products we all know, such as SIM cards, payment cards, or biometric passports, for instance. So for those who are not familiar yet with this ecosystem and the central role of JavaCard here, I really encourage you to watch the webinar from last year. It was called An Introduction to JavaCard Basics for Developers, which covers these topics and explains how to develop a JavaCard application. So in a way, the webinar today, I would say, is a natural continuation of this previous one. So as I just described, JavaCard applications, they run into products not directly available on your PC or a laptop. And today, what we discuss is a path from turning source files into applications that in the end actually will run on SIM cards, passports, or mobile payment wallets. The point is that first, because of the sensitive nature of these products, having access to them for application development, if it's even possible sometimes, typically comes with many restrictions and often requires agreements with the corresponding chip and card makers. And second, even once you gain access to cards for development, their availability, and number is limited, and they come with constraints like securing the location or the need for a card reader in your development environment. This makes the process of testing and debugging applications slow and complex sometimes. And the JavaCard development kit provided by Oracle is designed to address these issues, and its goal is really to simplify the process of developing applications into final products. It can benefit both to new third-party developers or any experienced ones who will be able to reuse then components they have already developed. To achieve this, we rely on 5 pillars, I would say. First, a standalone development environment on a PC or laptop integrated within an IDE. It's really a key element here. No need for a card reader or a card or any additional hardware in general if we think of embedded secure elements, and no need for further proprietary software as well. To support a wide range of use cases and provide the best experience with the latest features, the kit supports the most recent version of the JavaCard specifications. Then an important point is the complete debugging experience provided by the kit, where all is integrated into an IDE. However, we will see the architecture also allows for alternative debugging methods. Facilitating application testing is a key point, and the kit makes it possible to reuse existing tools and infrastructure that you may already have or are familiar with. And at last, compatibility with standards is really essential here. So an application for sure provides specific functionalities, but its development is also bound to how it is accessed and how it is deployed. And for this purpose, beyond JavaCard, the mechanisms for managing, deploying, and communicating with applications are similar as on final products when you are using the JavaCard development kit. So this kit, it comes with 3 components. The first one, tools. They are used to convert and verify JavaCard applications. They are a cornerstone of the JavaCard split virtual machine architecture and the deployment process. So as mentioned earlier, if you're not familiar with these concepts, I encourage you to watch the webinar from last year. But just to say that having these tools in the kit ensures that the application development process is really consistent with real-world products. Note that the tools, they cover the last 3 versions of JavaCard. Then the simulator. This is a standalone application available for both Windows and Linux. It provides a runtime environment to execute JavaCard applications. And the third component, the Eclipse IDE plugin, it makes easy to develop, test, and debug JavaCard applications. The Eclipse ecosystem is robust and well maintained, offering many additional plugins that can be reused alongside the one we provide in the kit. So where to find those components? On our Oracle website, I put a few links here. where you can download the different components, where you can find the documentation, which comes with release notes and user guides, where you will learn how to do the setup, which are the supported features, how to run samples, how to use a plugin, how to debug applications. And we also maintain a developer forum where you can find helpful information, ask questions, or report any issue. Looking at releases, the latest version is 24.1. It was released, as I said, last month in October, and the next release will be 25.0, sometimes mid 2025. So since, as it has been said, so you will have access to the slides, so I put all the links about the release, as well as the JavaCard homepage and blog page, where you can find useful information. So said that, now let me describe into more details the features of the development kit. As mentioned earlier, so the JavaCard Development Kit simulator supports the latest version of the specifications. So to date, this is the version 3.2. And because the versions are backward compatible, it also then covers all previous versions. To address a wide range of use cases and provide the best experience for developers, the kit includes a lot of optional features. Some of these features are related to the framework or are utilities. For example, it is common in products to support integers, garbage collection, extended length APDUs, multiple logical channels, all of which are included in the kit. And additionally, there are utilities to help with tasks like parsing TLVs, for instance. An interesting feature is the support for extended cap files, which allows the execution of cap files larger than 64K and containing multiple packages, some of which can be private. This is useful in certain use cases, such as enforcing access control policies or managing multiple schemes within one application. Some of the supported optional features are for implementing security protocols. For example, the sensitive result API enables assertions during critical protocol operations. This control flow integrity is typically needed by certified applications. So as you can see here, the kit also supports sensitive arrays to check array integrity, the system time API to monitor the duration of operations, or a certificate API and monotonic counter API, all of which are necessary sometimes to implement certain applications. Of course, cryptography plays a central role in developing security applications, and the kit supports all cryptographic operations required by security protocols. You can hash messages, you can generate random numbers, you can sign and verify messages, you can encrypt and decrypt data. You can also perform key agreement or key derivation operations. So the kit actually really provide state-of-the-art algorithms, modes, and schemes, and their keys. So I put here as a summary a table of all the supported combinations. So then application management. So how an application is deployed has really specific implications for both its development and testing. And because of this, the development kit not only supports the JavaCard framework, but also provides support for GlobalPlatform, which is today the industry-leading standard for application management in secure elements. With the latest 24.1 release, the simulator is now compliant with the Common Implementation Configuration version 2.1, which enables the management of multiple hierarchies of GlobalPlatform security domains. And this actually permits to reflect the business cases, business models, which are today established by the secure element industry. So here I put a summary of all the global platform features which are supported, as well as the version. So 2.3.1 for the card specification, 1.6 for the card API, SCP-03 for the secure channel protocol. But here, if you need more details, please, I encourage you to look at the user guide. Additionally, the development kit includes a proprietary Java API called the Application Management Service API for performing certain application management operations, or at least basic ones like installing or deleting an applet. But note that other APIs, as we will see, or other APIs or tools can also be used or reused based on our architecture. So note also maybe here the word applet. So if you're not familiar with this, it stands also for Java Card application. The API for communicating with a smart card from a host environment is based on industry standards, and the simulator is aligned with two of those standards. The first one, the Smart Card I/O API, it defines a Java interface used by Java applications for communication with smart cards through APDUs. The benefit of using this API with the development kit is that developers can fully develop and test their applet in a simulated environment using a Java application at the host level, and later they can play the same scenario with a real card to finalize the applet validation on target. The simulator also supports the PCSC, so Personal Computer Smart Card interface, allowing communication as if the simulator were actually a card reader. This option offers even greater flexibility, as many client applications and tools rely already on the PCSC interface. So for example, you can use validation tools based on PCSC in the simulated environment, and then reuse them directly with the final product, which involves the recard and the card reader. So today, the PCSC feature is only supported on Linux for the version 24.1, but there's more to come, I would say. So again, both communication methods allow developers to interact with Java Card applications on the simulator as they would with applications running on real Java Card products. And we can make things even a step further based on the communication architecture of the development kit. So actually, regardless of the interface, the underlying implementation uses TCP/IP layer. And in addition, the kit allows users to configure different addresses and ports, really offering multiple combinations and a lot of flexibility. So this capability is very useful for reducing the testing time, and it permits an integration into your existing infrastructure. So here I put a diagram where we can see on the right multiple instances of the simulator that can be used to run different or identical applets. And those instances, they can receive commands from different test frameworks running on the same or different machines, as we see on the left. So while this might seem like an extreme setup, it demonstrates really the wide range of possible combinations here, and some of them actually are used today. So before handing over to Syamkumar, I would like to highlight a critical feature of the development kit, so the debugging of Java Card applets. Let's take a closer look at the architecture used for this feature. The Java Debug Wire Protocol, so JWP, typically used by IDEs, is too heavy for the small Java Card virtual machine. Instead, the simulator uses a lightweight proprietary protocol. And for this, as we see here on this picture in the middle, a dedicated debug proxy component translates commands and responses between the simulator and the IDE. This is actually, finally, how applets are debugged while executed outside the Eclipse IDE. Moreover, this setup allows for a very convenient debugging experience where both the applet and the client application can be debugged together fully integrated within the same Eclipse IDE. However, here also, I would say the model is very flexible. So first, client applications can be run outside the Eclipse plugin, either as command lines applications or within another IDE, just based on the Smart Card IO or the PCSC interface. And second, because the simulator, the debug proxy, and the IDE, they communicate through sockets, you may debug using a remote host, and you can imagine even that a different IDE is used for debugging the Java card application. So this will be shown by Syamkumar, this part. So said that, I would like to thank you for your attention and pass the end to Syamkumar, who will demonstrate practically many of the capabilities of the development kit we just described.
Okay. Hello, everyone. Thank you, Nicolas, for providing a great introduction to the Java Card development kit and also covering its features. Now, as part of this presentation, I will cover different Java Card development workflow steps, starting from environment setup and also until the deployment and also the testing part. More importantly, what I will demonstrate today is how an Eclipse IDE is playing a central role for my demonstration and doing all the steps within this Eclipse environment. For completeness, I have consolidated some important steps required for the setup of the environment. Yeah, but anyway, I will not go through all of them. And please refer, as mentioned by Nicolas, simulator user guide for detailed steps, which is well written there. Now let us go in action, and without further delay, let us see some steps how we do this from the Eclipse environment. Like I mentioned, this is how the Eclipse workspace looks like when I created very first time. Like I mentioned, I have done all the setup necessary setup steps. Now let us start with the first Java card applet development. Let me create here. First, you have an option to create a Java card project. And very quickly, let me provide the inputs here. Like for example, some let us now create today a calculator applet. And for that, the necessary inputs I will be providing here. For example, package name and AID and also the applet name. Now let me finish this. Now you see the project is created and immediately even the compilation and conversion steps also triggered now. Now, like before developing a calculator applet, actually we need, let us see how we do the library development. Let us code everything in a library. For that, let us create again a project. Like I mentioned, this time not the applet project, but it is a library project. Let us name it as calculator lib and the package name. Like I mentioned, this is the library project. I don't want to create an applet. I can unselect this option and click finish. Yeah, you can see some errors now here because there is it's an empty project. I have a code which I already created for calculator library. Let me paste here. We have to keep it under the proper project. The calculator lib actually requires a package. Yeah, now you see here the applet, the library project also has been converted properly and a cap file has been generated. Now let us see how we can use this library project and actually develop an applet. I have the ready-made code already here, like I mentioned. Let me copy paste this. Now you see here under the library project, the applet project, it is using the libraries from the another project. Now, how do we resolve these steps? Like for example, now I need to add to the build path of this applet project. I need to add a library project as a dependency. with this step, actually you can see the applet patch also compilation errors are gone, but still converter is failing. That is because converter is not able to find the exp file. Now let us solve that as well. I can edit here, like under the export path. All I need to mention is the calculator library, the path where the exp file resides. This is where the library project has the path for the exp. I just finish it. Now you see here the calculator applet is also running fine. I mean, it's been created. This is how actually in the real time you can add a dependency to the source projects. Very similarly, you can also add dependencies to your, for example, third-party libraries, for example, GlobalPlatform or any other libraries which you want to use as part of your project. Uh, Basically, I'll just show you very quickly how to do that. Java build path. In the libraries, you can add your jar file here, the third-party library. And also similarly, how I added the exp file location, you can update for that particular project the exp file location, and then it should work properly. Even the third-party libraries, you should be able to integrate with your project. Now let us move here. And also one quick step what I want to show is under this, we have an option where you can create another Java card applet under the same package that can be triggered by using the option what I shown here from this option where you can say new and say Java card applet. Now let us go to the next step. Now let us see how we can do the applet debugging. Like we have, how can we launch the simulator and how the different run configuration and debug configurations can help here. Now, if you see here Java card view, it has a option where it has already added the default sample device. Now I can right click on this and I can simply trigger start. Now you see that simulator has triggered. Now under console view, you have different options basically to load this whatever, for example, entire applet management can be done. For example, loading an applet or whatever you want to do. I think all the options are provided under this view here. Now, let me kill this. Now, how do I automate these steps? Like, for example, loading and all, no need to do from the console view. This is where the configurations help here. Now, under run, like for example, let us say calculator applet. Now we have an option here where under run as and run configurations, actually you have where you can automate these steps. For example, you want to start the simulator and also add from individual steps. Basically, you can do here different commands. You can add it. For example, I want to load, install, and the moment I click run, simulator will be started and all the commands will be also injected. Now let us see the same with a different use case with the debugging. Now let us debug now the applet project. Like I will go to the debug configuration here. Now you can double click here. Now let's say, for example, you can name it whatever you want here. Now, if I go here under the Java card tab, the main calculator applet needs calculator library. That is what we discussed now. Now let us add now from the calculator lib, which is present under this path. Now this should be in order up. Now the moment I say here add command, now it will show the cap file options also. For example, I want to load. For applet, what I want to do is load, install, and select by default. Now I click OK and apply and say debug. Now the actually the simulator is launching now, and also the debugger proxy is launching. And if even you see here, select applet has been select command has been sent to the calculator applet. Now let us debug this. For example, put a breakpoint into the calculator applet process method. This is what is the entry. Now, for example, let us issue addition command. Like as part of the calculator, we have 4 options: addition, subtraction, and multiply and division. Now let us, from the console itself, you should be able to send it. Now the moment I send the command, it immediately switches to the debug perspective and the breakpoint will stop here. Now actually you can go line by line. For example, fetch method. Now for example, this is where the library we are using. We can go inside the library project and actually do all the debugging, like what are the values of it, and display it in a hex format or whatever. This is how actually we debug applet project and also the library and do end-to-end debugging. Now let us kill this app. Now let us go to the next step. Like we have covered now all these options. Let us now quickly see how does the Java code applet deployment and testing phase. Like yeah. Now, actually, Nicolas has mentioned about application management as part of his presentation, right? Where amservice.jar, which is actually a proprietary jar provided as part of the development kit, helps in different deployment steps like load, install, delete of applications, everything. This is what is the central of this package, the library, what we can say, the amservice.jar. Now let us see this also in action. Basically, let us go through this the am service.jar and how to use it for deploying your application. For that, now again Oracle has provided uh, use cases or different examples for that. Let me import. Like now I will navigate to the simulator, and under that samples, this is where the wallet example. Now you can select this folder, and I want to copy these projects into workspace and click finish. Now you see here wallet applet and wallet client. This is what I'm talking about, AM service API, which is provided also as an example. Now you can see here the code, especially the wallet, like a client code, where AM service API are used. Like for example, how to create an cap file object and how do we open a session. Basically, then we have to get an instance of AM service object. Then we can create a different AM sessions, and all of them we can add it to the script. And for example, in the end, get an instance of the terminal by using AM service socket provider. This is where it is providing abstraction for the smart card IO, and then we can actually execute it. Now let us see this as in action. Now, now simulators are running to make sure. Yes. Now let us launch the simulator. Start the simulator. Now, the moment I do this, Eclipse already connects from here. Now let us disconnect here. Now AM, now let us run this client. For example, I can run on this, run as wallet example. You see now this by using AM service, we actually did a lot of steps in like entire applet management, including the applet loading or cap file loading, installation, and sending a lot of commands as part of the wallet application, like debiting, crediting, getting balance. Everything is done, and all the steps have been automated by using this now. This is what is the tool provided by the Oracle. Now we have seen the code. Now let us see, now switch back to the how we can use this application management service API and do some kind of a test. Now for that, let us use now JUnit. For this also, JUnit also uses actually the same library what is being provided and to the applet management. And then as a framework, it provides a lot of other options. For that, to demonstrate, let us quickly see. Now before that, kill this session. Now, basically a JUnit, I think most of the Java developers should know very clearly. This is open source framework provided by the JUnit by for doing the testing. Now, for that, to quick introduce about JUnit, let us create, for example, JUnit test. Let us create one sample project here. I created one project. Now, I have one simple example to demonstrate JUnit. Now this is what is the sample. Let me explain this now. If you see here, actually compilation errors are coming because now it is a simple Java project and I added the code and it has some dependency to the JUnit. Now how do I resolve this? I will go to the project properties, Java build path, and go to the libraries. And under the class path, you can add a library and it called JUnit and select JUnit 5, finish, apply. Now you see here all the errors has been resolved. Now let me execute this and show you step by step very quickly. If you see here, what is been provided with the JUnit 5 as part of the test framework, it has basically a lifecycle methods where before all is executed only once before executing all of the tests, and after all is executed only once after completing all the tests. Now for each, we have a 3 tests here. For each test, before test is executed and after test is executed, this is where we can do some kind of a test management or required and cleanup and after each, something like that. But here, if you see, I have a 3, how it runs and looks like is, for example, test 1 is passing, test 2 is failing, and test 3 I ignored it. So this, I just want to showcase the some of the features. Like for example, if you want to make it pass the second test also, this what is the assertions are doing it here. Now I can simply rerun the test. Now you see test 2 is also passing. Now having understood what is JUnit and how it is helping us for this kind of testing even Java applications. Now let us see in action how the JUnit is helping us for even automating and testing the entire Java code applets also. For that, I have already a ready-made code available. Maybe let me take this. For the same wallet application provided by Oracle, we have now applet code and as well as a client code. Now let us see how does it look like from the test points of view. Now I want to copy these projects to the workspace. Yes. Now you see here the JUnit wallet tests are there. Again, like I mentioned, I'm using the same AM service library which is provided, and I've abstracted them some kind of a utilities here. And now you see the tests as part of before all. I'm doing a setup where I'm creating a CAF file object and creating a service object and then creating a session, all of that. And after all, I'm actually deleting and cleaning up my simulator, unloading it and uninstalling it. For each test, basically, I transmit select so that and verify so that all the tests run properly now. So this will be run for each test, but these two will be run only once for entire life cycle of the test. Now let us see again now how to execute this. Let me start a simulator, and as usual we should disconnect from here to connect it from a different client. Now I can show you how to run these scripts now. Like you see here, lot of unit tests, lot of tests have been run on the wallet, like for example positive test, negative test, but intentionally here I have failing test here. Now, to understand this better, let us debug this failing test. Let us put a breakpoint in this debug test. Now, let us see. Yeah, simulator is running. Yeah. Now, under this, we can actually trigger the debugging by clicking on this. Yeah, now see here, JUnits also can be debugged, and it switches to the debug perspective. Now I can go like step by step here. In fact, in the same session, what I could do is, in the previously I showed how debug can do an applet. I can launch, instead of launching an applet from here, from the Java view, I could launch this from the debug, and then so that the moment I step in and any command is sent, now you can parallelly debug even the applet. But for now simplicity, I just showing it, and yeah, I just executing it. But now you see here, just again to trigger here, just to show you one more time. Yeah, now when you debug here, you understand that basically I'm doing a credit, but I'm sending a credit test, but I'm doing a debit test here, just for simplicity. Now let us correct this. This is what we understood. Now click it. Now you see here JUnit, it is passed. Like you can trigger now valid test completely. So now see all the tests are passing now. This is how you can use the JUnit framework, which really helps in even automating and even in testing the Java card applets by using the AM service and then writing the tests and integrating seamlessly. Now let us go to the next step. Basically, now how do we automate? See, now I want to introduce here an Eclipse IDE framework. Basically, this is a sub project under Eclipse itself. It's actually an abstraction over multiple scripting frameworks. Like for example, you see here different scripting frameworks like JavaScript, Python, Ruby. It supports all of them. But for today, let us talk about JavaScript and see how the JavaScript is JavaScript will help us on even doing this kind of automating these day-to-day tasks and end-to-end automation now. Like for that, again, let me kill the simulator. Now for that, again, I have a project created. Let us import that project now. In the same path here, demo code, I have here JavaScript is. First, let me import it and I will go through very quickly on this. Like for example, I can import and copy the projects here. Yes, now you see JavaScript is has been there. Let us close all of them now. Actually, what E supports is it supports a separate perspective for doing this programming. Now, let us go to the scripting perspective here. Now, if you see in the scripting perspective, there are some shells are there and some module explorer. Now, let us go one by one very quickly on this topic. Like, for example, I have a script here for the loading of a cap file, what I shown from the AM service library. I'm using the same AM service library, but I actually written a simple script to demonstrate this activity. First, let me execute this. Before that, as usual, we need to start the simulator for this activity. Start the simulator and disconnect it from here so that scripting can connect now. Now, let me show you how to run this script now. eScript. Yeah, you see here, actually it is already, even it is executing deploy and undeploy options, where deploy under that, we are loading a cap file, installing it, undeploy, we are uninstalling and unloading, all have been successfully executed. And you can see actually output also from the response. Now, actually you can even drag and drop here. So actually it will, again, it will automatically run that, like a lot of functionality provided by the ease. Now let us see how we can even debug the scripts. For example, I can put a breakpoint here and I can see here debug as eScript. Now see here, the moment I say, it automatically triggered to the debug perspective again. Like you can debug Applet, you can debug JUnits, and you can debug even script in the same environment in the same way. Like you see here, a lot of variables here, what have been injected from the Java, and you can see the values of all of them, and yeah, it is seamlessly working. Now, as part of ease, what we also have a very good help document. In fact, and what I can demonstrate also is we can also automate this entire steps. Like I can run all these scripts even from a command line, which you can see from the scripting user guide, and you can see here headless integration also can be done. Yeah, this is what I want to very high level show on the automating how we this can be done using Eclipse is. Now let us quickly cover some additional use cases. First, let us see, like Nicolas was explaining, right? The architecture is very flexible. Now let us see how we can debug based on the same tools, but using this time with the IntelliJ idea. For that, first thing, make sure is you kill this simulator from here. Yeah, just to make sure. Yeah. Now, actually, I have all steps here. Like, let me open the command line. Basically, what I'm trying to do now here is to debug the same wallet applet, what is provided by the Oracle. Now, I want to debug this time with the Oracle, with the IntelliJ idea. Now, first, let me, as part of that, build the project. The building project is successful. Now, let us open another tab. Now, launch the simulator from the command line. Yes, simulator has been started. Now, let us start the debugger proxy also from command line. Yes, debugger proxy has been started. Now, all I have to do is, under IntelliJ idea, I just created a wallet project and imported the same sources from the sample. But we have to create a configuration called remote JVM debugging option here. And I have configured the same port where I am starting the debugger proxy. And then I can say, for example, click on debug. Now the debugger, now the Eclipse, IntelliJ idea is connected to the instance of the proxy. Now let us see in the first console, let us run some use cases, for example, wallet use cases, right? We ran earlier some simple use cases. Now let us run them. Yeah, the moment it triggered this, it actually stopped here. Now you can see here the same, it is sending as part of the use case, it is sending multiple APDs. Now you can see here this select application. Now you can debug into or step over or step into, like any other IDE. You can it can support a lot of debugging options. Like for example, next APD is coming is some like let us see what is this APD now. Yeah, this is a get balance APDU. Now let us go into the get balance. Like we can do this everything seamlessly from the IntelliJ idea also. Now let us suppress the breakpoints. Let us execute this, and you see here it all run properly, and 33 responses we have received now. Now let us kill this simulator. That's what I wanted to show as part of this. Now let us go to the another use case very quickly. How what I did as part of this assignment is, and from open source I took a Fido to Applet, and it has some tests which is based on a open source simulator. But now I'm using now Oracle latest simulator and execute the same test, and let us see how it works now. Let us kill this all the simulators now. For that, again, go to the Eclipse environment, Java perspective. Now let us import the projects what I was mentioning just now, the demo code, Fido2 projects, copy all of them into workspace. See here, these are the Fido2 applet provided in the open source, and these are the tests as part of that again what they have provided. But now the same test without much changes, except the applet management part, I restructured them so that we can even work with these kind of any other projects. Like for that, again to demonstrate, let me start the simulator. As usual, disconnect from here. Now this is the test, like run as applet basic test. Now you see that they are all running now, instead of an open source simulator, now they are running an Oracle SDK simulator, and executing all of the tests are successful. Like I said, again, the main crux here is using the same AM service library. What I only refactored is before each, and the after each, like where the similar functionality I just adapted. So, but everything, the functionality wise, all the tests as it is, there is not even single change except minor adaptation where it will connect to the channel. But otherwise, all the things are working very much fine. These are about the applet. Now, one last thing I want to show is how Smart Card IO, like Nicolas was showing in his slides, how it can provide an abstraction for a simulator or even PCSC. That is what I want to quickly show now. Like for the same valid test now, let me again kill this. See, for example, here I have one test. Instead of running this on simulator, now I have changed this to run on, I'm passing option 1. It means it will connect to my local reader, which is really my local PCSC reader. Of course, this I cannot execute and show. But what I want to say is, with the simple code adaptation, you can run the same test what we have developed for valid test with either card or a simulator seamlessly, because the smart card IO is providing us as the required abstraction. Yeah, this is what I want to show and highlight, that the smart card IO is the standard in general smart card connectivity. Yeah, now we have covered all of these use cases very quickly. Yeah, now I would say I have done with my presentation. Now we are open to questions. If anyone has some questions, some clarifications, we would be happy to help answer them.
Yes, can you hear me, Kumar?
Yes, I can hear now.
Yes, thank you for the presentation, and Nicolas also. We have a question from the audience. Before I jump to the question, I have one myself. I think all this is very interesting and useful for developing on, I would say, on the Linux or Windows platform with PCSE, as you mentioned, which is a standard, but I would say the mobile is the new PC. So, and the standard on the mobile is, for example, OMAPI. So, first question would be any plans to support either a mobile simulator like the Android one or a real mobile through the OMAPI interface. That I think that would be useful for the industry, given that people are starting to develop applets for third-party markets, like, for example, cryptocurrencies or identity applets.
Yes, so this is indeed something we study. So as you saw, the architecture is very flexible. So it might be that we would provide a way for an Android application, for instance, to communicate to the simulators through a socket when you are using an emulator for Android, etc. So this is something we studied. I cannot commit on any plans in particular, but it's a good point you mentioned that this is something which is interesting to provide also. Yes.
And, another one, and then I jump to the question of the audience is there's a support for, I would say, some global platform configuration. And I think GlobalPlatform is such a number of amendments and configurations, and I would say any plan to cover different configurations and more features of the GlobalPlatform specification?
Yeah, so today we support the common configuration, which permits to play the broadest number of use cases, I would say. And yes, we will improve the supported GP features and add support to of a few amendments. So this
Okay.
is something we have in the roadmap. Yes.
And is it something that Oracle is planning to do on its own, or is there a plan like to have a community of people working on it, or having GlobalPlatform involved?
No. So it's Oracle is providing the simulator, so we develop the corresponding features. Yes.
Okay. And so I have a question from the audience, which is JF. I don't know who's JF. Excuse me, do you have an example about the use of an external test tool sending APDU via IO to simulator, and also for debugging this?
Actually, I would say here, of course, we have some tools which will do the smart card IO. But more interestingly, like Nicolas was mentioning, for Linux, we have the where the PCSC drivers are provided. And also Oracle has some plans in future to provide also the looks like from the roadmap Windows also the PCSC driver. Once this provided for the Windows, then actually these are very seamless. Whatever is the PCSC standard, you have many tools or whatever tools provided, those can also easily connect to the simulator and can work.
Okay, so I hope it answers the question. And so the microphone is open if you want to ask directly questions to Syamkumar and Nicolas. Looks like it was pretty clear in terms of presentation. So if there's not any more question, I think we can close the meeting here. Thanks, Syamkumar and Nicolas, for this presentation, and I think this will be probably very useful for developer of Java card that want to test their application and deploy, especially for new markets who don't have that kind of skills. The presentation is recorded. It will be available, as I said, as a YouTube presentation or also on the JavaCard Forum website. That's only the third one of 6 of the webinars for this year. So if you want to stay tuned and register to the other one which are coming, I think we have a great content. And also, if you're new to this webinar series, you can also connect to previous year's webinars, including the one that Nicolas mentioned on the introduction to JavaCard that was given last year. So thanks again for attending, everyone, and have a good day or good evening for all of you.
Thank you. Thank you.
Thank you.
Bye.